This you already completed. So I'm going to show you how you are going to draw cyclic structure of glucose. So you know that this glucose, this is your Fischer projection in which carbonyl compound is this. So when you are going to write the carbonyl compound, you know that oxygen is more electronegative, so it can be broken in this. And you are going to take the last chiral carbon. This is your last chiral carbon. This is hydrogen positive and this is negative. Now this hydrogen positive is going to combine with this negative OH, so it becomes OH like this. And this negative O negative is directly going to combine with oxygen, so it will be like this. Are you getting my point? So there it becomes the cyclic structure. There it becomes the cyclic structure. Now, the most important point is that you are going to write how you are going to write. So very simple. This is first you are going to number it from here. The starting carbon 1, 2, 3, 4, 5 carbon, and the sixth atom in the cyclic ring is your oxygen. That means it is heterocyclic structure. Now, how you are going to write it? So the cyclic structure is known as Haworth projection formula. And since six carbon is there, so you are going to write a cyclohexane type in which one of the corner is filled with oxygen. Now I'm going to take this as 1, 2, 3, 4, 5, and 6 is oxygen. Now you know that on the first carbon, if you are going to see this, I took it as a first carbon. OH is on the right hand side and H is on the left hand side. So what you need to do is very simple. Cyclohexane, I'm going to cyclohexane type, I'm going to draw the structure. It's like this. Okay. Now this is bonded. So you are going to write like this, the bond. Now, which one is going to be written on top or bottom? That is completely depend upon which is on the right. Whichever group is on the right, that will be written on the bottom. And whichever group is on the left, that is written on the top. Very simple. So in the same way, if you are going to see, you can write up to this fourth carbon. Fourth carbon, you can see OH on the right, so it is on the bottom, H on the left, so it is on the top. And on the fifth carbon, if you are going to see, there is no left and right that is left. So there is hydrogen and CH2OH. So this is completely based upon molecular weight. Whichever has more molecular weight, that will be written on the top, and less molecular weight, that will be written on the bottom. Is that clear? Now this is, its name is alpha D positive glucopyranones. Alpha and beta is an isomer basically. If on the first carbon your H is on the right hand side, sorry, OH on the right hand side, then it is alpha. And if you are going to switch that position to left hand side, then it is beta. That is isomer. D is basically capital D will represent last chiral carbon. If you have OH on the right hand side, OH on the right hand side, then it is D. And if you are going to rotate this and shift this to the left hand side, then that will be capital L. This is different from a small l or a small d. This positive is your dextro, that is a small l. Gluco, that comes from glucose, and pyranose, it looks like parene, so it is pyranose. So we call it alpha positive glucopyranose or alpha D positive glucopyranose. Is that clear? Everything is written in the notes that I gave you. Okay. So if you got it, can you please draw the structure of this? This. This is your, I just switched the position. This is your beta. You can see on the first chiral carbon now you have H on the right hand side. H on the right hand side. So what will happen on the first carbon H on the right hand side? So H comes on the left down, and the rest part is as it is. And this has a name beta D positive glucopyranose. And you know this is called C1 anomer. Anomer. What is anomer? Basically, anomer or diastereomer, non-mirror image. And C1, why do we call it C1? So C1 is basically we are switching on the first carbon, first position. That is why it is called C1 amide. In the alpha, if you have seen OH on the left, that sorry, OH on the bottom and H on the right. And here beta H on the bottom and OH. So switching position is the first carbon. That's why C1 is that clear? Let me know when you are done with this. Then yeah, you have the notes, so you don't need to write that. Now again, the cyclic structure of fructose, as I told you, glucose is aldo and this fructose is keto. So this is how the structure of fructose looks like, in which ketone group is there with polyhydroxy, glucose aldehyde with polyhydroxy. So again, with the same thing, this is your carbonyl. So this will be negative, this will be positive. This is your last chiral carbon. So negative, positive, and you can connect this. Now you can see this will be broken and CH2OH moves to the left hand side like this. Okay. Now, if you're going to count the number of carbon, it will be something like this. Wait a minute. I should write like this. This is one, two, three, four, five. So the cyclic structure is in between second, third, fourth, fifth, and the sixth. That means fifth of in cyclic member you have five atoms. That means cyclopentane type. So I draw this, and now again the same thing. OH on the right that will come below. CH2H on the left that will come above. Okay. H on the right below. OH on the right below. OH on the right below. And then the fifth carbon comes. The rest you are understanding that H on the left, that is above. Okay. And here OH on the left, that's why it is above. But when you are going to talk about this carbon, just wait, this carbon, this has neither left nor right. So what you need to do, molecular weight, CH2H on the right, more molecular weight. So this will be the same. And it has a name, alpha D negative fructofuranose. As you know that fructose is livorotatory, that's why negative. D, because last chiral carbon, if you have OH on the right hand side, that's that's why it is D. If it is on the left hand side, then it will be L. Alpha and beta is an isomers. The switching position, if you are going to switch this position to the left, then it becomes beta. And in this, the anomer is C2 anomer because the switching position is second carbon. The first carbon is this. Are you getting my point? And in this chiral carbon is 3, chiral is 4. Let me know when to change this slide. In the same way, we can do for beta as well. I did beta here. What we need to do for beta is very simple. Switch the this. So this is the first, second. So this is called C2N1, and the rest part is as it is. On the last carbon, when you don't have left and right, so you will follow molecular rule. Okay, done. No. After the say, after this structure of sucrose. So sucrose is disaccharide. When you are going to hydrolyze sucrose, you will get fructose and glucose. So how we are going to draw the structure of sucrose? So basically, what you need to do this to draw the structure of sucrose, you are going to combine alpha D glucose and beta D fructose and eliminate water, eliminate H2O. So this is your alpha D glucose and this is your beta D fructose, and I eliminated this water. The rest part will be as it is because they will be connected. Now they will be connected with each other, and this is the structure of sucrose. See this connection between beta alpha D glucose and beta D glucose through oxygen, that is called glycosidic linkage. And the position of glycosidic linkage is very important. If you are going to see the glycosidic linkage present here in C1 and here, this is your C2. C2 for fructose. So the glycosidic linkage in sucrose present between C1 and C2. So this is very important, the structure of sucrose. So in order to draw the structure of sucrose, you need to know the structure of alpha D glucose and beta D fructose. Is that clear? So you have to remember. Can I change the slide? Now again, these are repeated same thing, maltose, how you are going to how you are going to form maltose. You can see the monosaccharides are given and then you just need to remove H2O. In the same way, the starch is there. So in a starch, this is very important. There are two components in a starch, amylose and amylopectin. These are some theory which is very important, out of which this linear polymer of alpha D glucose, a right linear polymer of alpha D glucose in a straight line, and then remove water. Since it is polymer, so you can take 3 or 4 alpha D glucose and remove water from there, you will get amylose. And amylopectin, amylopectin is basically branched polymer of alpha D glucose. So I can show you. This is the scenario. This is amylose, linearly polymerized alpha D glucose and remove water. So you will be getting this. This is your amylose. And what is amylopectin? Amylopectin is branched polymer. So this was a straight line like this, amylose, and then another alpha D glucose come in contact with this in a branch C6 and C1. So this is very important to note that alpha D glucose in this alpha links are called because of this is since this comes from alpha glucose, that's why we call this glycosidic linkage as alpha links as well. So there is this alpha links or glycosidic link are C1 and C4, between C1 and C4 and branched at C6 because this is connected at 6 carbon, that's why. Very simple this is. You can see alpha links we call it, or you can call it glycosidic linkage. Why alpha links? Because it comes from alpha group. Is that clear? You just need to remove water and get the last one from this. If you are going to see cellulose, the structure of cellulose. So basically, it is only also polysaccharide. Mhm. Linear polymer of beta D glucose. You just don't need to do anything. Write the beta D glucose linearly. Glycosidic linkage here is in between C1 and C4. There is no branch here. And this glycosidic linkage is also known as beta links because it comes from beta glucose. So this is your beta D glucose in which you just need to remove water. Remove water. Now this is your beta links or glycosidic linkage. The glycosidic linkage or beta links is in between C1 and C4. This is your C1 and this is your C. So I think it's very easy. Okay. Are you done with this? Okay, now I'm going to start the second part of this chapter. Right with me, very easy. First of all, we are going to talk about amino acids. This chapter you can divide into three parts, very small and very easy. The first one is carbohydrate, another one is amino acid, and then proteins. So amino, that means amine there will be, you can see. And acids, you know that carboxylic acid. So amino acids are organic compounds, right with me. Amino acids are organic compounds which contain amino group. That means your NH2 group and carboxyl. That means carboxylic acid. You know that is classification of amino acids. So basically, this classification is on the basis of a relative position of amino acids NH2 group. So you can write classification of amino acids on the basis of a relative position of amino group NH2 and carboxyl group. Right. Very simple. You just need to write it all are theoretical. Let me know when you are done with this. Are you done with this? Now see, if you have this scenario, C double bond OH, it is the senior most functional group. This is carbon, another carbon, another carbon, another carbon. Let's see. So with respect to this carboxylic acid, this position is your alpha. You know that this is your beta, this is your gamma, this is your delta, right? Now, if you have C double bond OH, carboxylic acid, and this is your C, H, H. That means basically two alpha carbon, if NH2 is connected, this is called alpha amino acid. This is called alpha amino acids, and its name is basically glycine. Its name is glycine. Just wait. Yes. Its name is glycine. And we represent one letter code for glycine, three letter code we write GLY, and one letter code we write capital G. Everything is present in the NCERT table 14 point. Is that clear? Now, if you are going to write this like C double bond O, OH, carboxylic acid, and this is your carbon, CH2 is there. Then another CH2 comes, and this with this CH2 there is NH2. You can see with respect to carboxylic acid, this is your beta. So we call it beta amino acid. What we will call it beta amino acids. Is that clear? Right. In the same way, you can go for gamma and delta. Are you done with this? Now see, the second classification of amino acids on the basis of pH value. So very simple this is. If pH is less than 7, that is acidic, greater than 7, basic, equals to 7, neutral. But how you are going to find it? So basically when NH2 is your base, right? And carboxylic acid is acid, you know that. So number of, we roughly do this, NH2 is equal to number of COH. Both are equal, then it becomes neutral amino acids, almost equal to 7. If number of NH2 group greater than number of carb, then basic amino acid. Third one is number of NH2 is less than number of carboxylic acid. That means carboxylic acid is greater than acidic amino acid. Let me know when you are done with this. Now see. This is the third classification, which is very important. So please be focused. And here it comes, classification of alpha amino acids or amino acids on the basis of requirements. This is very important. So there are two types of amino acids, and one is essential, another is non-essential. So essential is what? Essential amino acids are those which does not, we don't get it from our body. Basically, we need to take it from outside. That is your essential. And the one which we get from our body, which releases by our body, that is non-essential. So write it with me. Those alpha amino acids which cannot be synthesized in our body. This must be present in our diet. From outside, we need to take. If this acids, if you are not taking for longer time, then it will be bad for health. If these are absent in our diet for long time, it may lead to deficiency. Lead to deficiency disease. For example are very important. I'm going to write on the left hand side. VIP, to remember this, VIP. V stand for valine, I for isoleucine, P for phenylalanine, phenylalanine. I can write the another one, PMT. P is same, phenylalanine. M is methionine, and T is tryptophan. These are all tryptophan. These are all essential amino acids which we need to take in our diet. Let me know when you are done with this. After this, we have non-essential amino acids that synthesize in our body. We don't need to take in our diet. Non-essential amino acids. Which cannot synthesize vitamin which can be synthesized in our body. So these are not required from outside. For example, glycine. You should remember which is essential and which is non-essential. Sustain. Let me know when you are done. So basically, examples are very important. They can directly ask to write the example of essential or non-essential amino acids. Okay. Now the next topic related to this is the structure of, especially we are going to talk about alpha aminos. Alpha aminos. Now see, this is your NH2. This is your hydrogen, and this R we will be changing. This is your C double O. You can see that this is your alpha, so that's why it is all alpha. What do we say? It is alpha aminos. Simple. Because NH2 is connected with alpha carbon. Now, see, if you are going to replace R with H, if you are going to replace R with H, it is your glycine. Alpha amino acid glycine. If I'm going to replace R with CH3, it becomes alanine. See, this is your CH3. I'm going to write this is your NH2 as it is. This is your H, and this is your carboxylic acid. So what I did is very simple. I just replaced this CH3 with R, and here I replaced this with H, and this has a name alanine. Are you getting my point? Good. There are some points which are very important. Alpha amino acids are optically active. Except glycine. Okay. Also, glycine is sweet in taste. Gly means taste, sweet. Glycine is sweet in taste. NCRT you will read, that is most important. Tyrosine obtained from cheese. Let me know when you're done with this. This is your alpha amino. Now, this is deuterion or dipolarian ion we can write. This is acidic, so it will release H plus. So this becomes C double bond O negative, and this is R. This is H, and this has a lone pair, so that nitrogen will donate it, and it will form a bond. We call it dipolarian or deuter. Deuterion is what positive or negative charge in the same ion. That is Z. So we can write deuter. Let me know any other. Next. The third part of this chapter is your protein. So you just need to write very simple it is. And in this first, I'm going to introduce this peptide link, or we say amide bond. You know what is amide is a functional group. So it will be something like this. Also, this is your amide. Okay. So we can write the amide bond or peptide linkage joins alpha amino acids. Alpha amino acids in protein. So in protein, what happens? Peptide bond is going to join alpha amino acids with the in protein. In protein. Okay. For example, I'm going to show you first right here. So this amino acids joins together to form peptide bond, which is present in protein. Let me know when you are done with this. Done. So the example, if you are going to, let's say, I'm going to talk about example. NH2, I'm going to write it like this, NHS. Then I'm going to take glycine here. So you know CH2 is there and then C double bond O. OH is there. And here I'm going to take another. Alanine I'm going to take. Alanine, you know, H is replaced by R is replaced by CH3. So CH3 is there, H was there, and then C double OH. Now what will happen? From this, H2 is going out, and from this, H will going out. Basically, H2O you are going to remove. So when you are going to remove H2O, that means nitrogen and carbon now will have a bond between them. And what type of bond this is, you can see C double bond O, nitrogen, then hydrogen. And the rest part is as it is. Here it is hydrogen, 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 CH3 is there. And then carboxylic acid, C double bond O, OH. And here comes your C, H, H. And then comes your NH. Now this is your peptide linkage. This is your peptide. Is that clear? And this is your dipeptide we saw. And we write GLY for glycine and ALA for alanine. Did you ask the three word shortcut or one word that is present in your NCERT? You can see that. Let me know when you're done with this. Are you done with this? In this part, you just need to write very simple like this. Now write polypeptides chain. So we can write it is the chain of alpha amino acids. In which alpha amino acids, poly, that means many, alpha amino acids are attached by peptide bond or peptide link. Peptide bond or peptide linkage or amide linkage. Right. Then we'll do classification of protein on the basis of shape. Let me know when you are done with this. No. Classification of protein on the basis of shape. This is of two types. Fibrous protein and globular protein. Now see, you just need to write very simple this is. When peptide chains run parallel and held by hydrogen bonding, H bond, and disulfide bond, and form cylindrical fiber. Cylindrical fiber like a structure. And then protein is classified as. I'll give you the structure as well. Fibrous protein, globular. When polypeptide chain is closed, coiled, not closed, they are coiled to give spherical shape. Then protein is classified as globular protein. There are other points that I need to write. Let me know when you are done with this. The next point, the second point about this, we can write it. Fibrous protein are insoluble in water, whereas globular solute, globular protein are soluble in water. Example, we can write keratin protein, and keratin is present in here. The second example we can write is myosin protein, MYO, present in muscle. Here is the example, insulin, that is albumin, that is present in white form. Right. Let me know when you are done with this. Now we are going for a structure of protein. So the first one is primary structure of protein. Write with me, very simple this is. It refers, that means primary structure of protein protein refers to polypeptide chain. This is basically linearly arranged polypeptide chain in which alpha amino acids are attached with each other by peptide link linkage in a specific sequence. As for example, like alanine, 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 glycine, alanine, mitosine, isoleucine, etc. Almost they are linearly arranged, right? This chapter is almost complete. The rest part I'll be sending the PDF, and in the next class, most probably we'll go into a study and explore. Let me know when you're done. Secondary structure protein. Now, what is secondary structure of protein? So, secondary structure, or we can write directly, it refers to the shape in which long peptide can exist. This is two types. There are two types of secondary structure. Types of secondary structure of protein. One is zero. We call it alpha helix, and another is beta plated sheet structure. Alpha helix structure. You're right. Are you done with this? Now this is also very easy. Alpha helix structure and beta plated sheet structure. So we can write a point about this. An alpha helix structure. Polypeptide chain is coiled in the form of right-handed helix and beta is in beta plated sheet. Polypeptide chains run parallel and are stretched out to maximum extension to form sheet-like structure. Form sheet-like structure. The structure somehow looks like this. Let me show you. This is right-handed helix, something like this. Okay. Spring type, a spring. And for this, it's data sheeted plate. Mhm. It's something like this. This is your, and this bond is basically hydrogen bond. Right. Done with this. Okay, so this is it for today. In the